Okay, good evening, ladies and gentlemen. Welcome to STEMWithKeno.com. I am Keno Thomas, and we're going to get into the live stream tonight. Make some adjustments here, and we'll get into the emails and the questions. Just be a moment. Anybody checking into the live stream, please tell me your location and the test that you're preparing for. We do this every week. For anybody new to the room, the military aptitude tests that we prepare for, or prepare people for, are the ASVAB, the AFOQT, the Aviation Selection Test Battery, which is the ASTB, the OAR for non-flight applicants in the United States Navy, Coast Guard, and Marine Corps, and the United States Army SIFT, which is the Standard Instrument for Flight Training. In addition to that, we prepare people for all Federal Aviation Administration computer test exams. Private pilot all the way up to airline pilot, all the instructor ratings, ground and air. Give me a moment as I check into my email. And if you guys can hear me, just let me know that the sound is good, and we'll jump in. If you want to take a snapshot using your iPhone or Android phone, you can send it to this email that I'm posting. On the message board. And we will jump in now. Okay, the first question that's coming in is dealing with scientific notation. Scientific notation is a way of taking very, very large numbers, or very, very small numbers, and then converting them into a workable form so they're easy to work with. I'll give you an example. When I talk about a very, very large number, let's talk about maybe like a number like 2 million. Or a very, very small number like 0.000002. All right, now while these are that's a very, very large number, that's a very, very small number, we can take these two numbers and we can actually work with them by transforming them. And scientific notation is the method that we use to do this. So let's take a number like 2 million. The first thing we need to do is we need to find out where the decimal point is. Now in this one, in a very small number, we know where the decimal point is already. So we look at the very large number, we look at the decimal point. And what we need to do is we need to move it into the area where you have your significant digits. And in this case, the decimal's here, and we're going to move it over 1, 2, 3, 4, 5, 6. So it's basically at 2.0, right? And we move to 6 spaces. So basically what we're going to have is 10 to the 6th power. So 2 times 10 to the 6th power is a very manageable number. It's not very large like this, but it means the same thing. 2 million is actually 2 times, and you don't need this 0.0. You can just have the 2 there times 10 to the 6th power. If we have a very, very small number like this, all right, then what we'll do is we'll move it here 1, 2, 3, 4, 5, 6. But we have to get the decimal. We're in a situation where you have one significant digit. And what I mean by that is it's a digit that is not 0. It could be 1, 2, 3, 4, 5, anything upward. So this will be, we move 1, 2, 3, 4, 5, 6. So this will be 2 times 10 to the negative 6th power. All right, so that's how we convert that. All right. Now, the particular question that the person sent in was basically converting. Where's one? So I wanted to just give you a background first. Now the actual question that the person emailed in, we're going to deal with. Now in this particular case, we have 71 times 10 to the 3rd power. All right. Up to the second one as well. So in this case, we have 71 times 10 to the 3rd power. Now, in this case, the decimal is here. And again, we need to move the decimal to the point where it's in between the most significant digit to the left, and then you'll have another digit. So it moves over 1. So we have 7.1. And then if we go this way with this, I like thinking of it like this. Like this goes in a negative direction, so the exponent needs to go in a positive direction, 1 point. So transforming 71 times 10 to the 3rd in the scientific notation is 7.1 times 10 to the 4th. All right, and the second one in the email I received, there is a large number, 48,900. Again, the decimal's here, and we need to move the decimal to the most left significant digit. So we go 1, 2, 3, 4. So this will be 4.89 times 10 to the 4th power. Okay, so I hope I answered I did answer 2 of your questions there. All right, so that wasn't too bad. Going back to the email. This email comes from someone, and it's like a question for why aren't there just full forces of flight? All right, this concerns aerodynamics or aviation and nautical information. It's really, really important that you guys understand now. There are 4, and this is for all the aviation candidates, there are 4 basic forces of flight. So we have our airplane. We have lift, we have thrust that the engines are producing, thrust, R-U-S-T, sorry about that. We have drag, which is the rearward force, and then we have gravity, or some would say weight. But it's important to understand that the total drag has subcomponents. The first subcomponent is induced drag. Just the fact that we are producing lift, we're going to get induced drag. And the second one is parasite drag. Parasite drag comes in a couple forms. Skin friction, profile, and interference. Make sure that's all getting on the camera. This is interference on the bottom. I'll just abbreviate that. Okay, so it is very, very important. While there are four basic forces of drag, which is the lift, thrust, drag, and gravity, when we break down total drag, it's comprised of induced and parasite. Now, induced doesn't break down anymore. The parasite breaks down into these three guys, which is a skin friction, profile, and interference drag. All right, so that was a good question. All right, going back to the email. Absolute value. We've been doing a lot of absolute value questions, and what you need to understand about absolute value does not care about positive and negative. It only cares about units moved, and that's why in the absolute value container, which looks like this, everything in this absolute value container is considered positive, even if it's a negative value. So if we have 6m equals 42, and we're trying to solve this, when we have this absolute value situation, this actually becomes two questions. It becomes 6m equals 40, and it also becomes 6m equal negative 42. So the negative, the thing that's on the other side of the equal sign actually takes a positive and a negative form, and then we just solve for both. If we divide both sides by 6 in this situation, we have a 7. And divide both sides by 6 in this situation, we have a negative 7. So it is said that the solution set for this absolute value question is 7 and negative 7. So if we plug the 7 in here, 6 times 7 equals 42. If we plug negative 7 in here, 6 times negative 7 is negative 42, but since it's within the absolute value container, it is considered positive. Percent problem in this case. Now with the percent problem, the question is asking us, what is 90% of 130 inches? What is 90% of 130 inches? Now, normally, our formula would be is over of is equal to X percent over 100%. And basically, we look at this formula and we look at what's attached to what. Now, what is 90%? So this is what we're trying to find out. So we're going to make the same equation, but we're going to plug in numbers. So this is the question mark, 90% of 130 inches. Over 100%. And this would be 90%. Now basically, in this case, normally what we would do is cross multiply and divide. So it would be 90 times 130, and then we would divide by 100. Now, there's two ways you could solve this. Myself, I would just multiply 130 times 0.9, and I would get a result. Or you could just multiply 90 times 130, and I'll do that here. But I will multiply 90, 13 times 9, and then add the 2 zeros later. So you don't have to actually go through 130 times 90. You have to understand you're taking a test that is it's time sensitive. So you want to solve it as quickly as possible. So I wouldn't do all this. I would just chop off the zeros, multiply 13 times 9, and then add the 2 zeros later. And 13 times 9 is 117. Add the 2 zeros. All right. And then after that, if we divide by 100, we just wind up cutting this off. So our answer is 117 inches. All right. I wouldn't have done all that. What I would have done is multiply 13 times 0.9 will yield 90%. All right, but I would chop the 0 off there. And again, I would get 117. Then I would add that 0 back. And then I have 0.9 here, so I have to bring in the decimal point 1 point. And I would still get 117 inches. So there's more than one way to skin a cat. You don't particularly have to do it this way or this way, but me personally, I believe that this way is the fastest. That's a good question. All right, exponents. A lot of people have problems with exponents, and exponents are really not that bad. I'm going to show you most of the situations you can get into with testing. And then I actually have a video that you guys can look into. You can just put in Keno Thomas and then exponents, and then on YouTube the video should open up. And for people in the room, how is my audio sounding? Just type good on the message board if you guys don't mind. But I always like to make sure that my message is getting across. Okay, so for exponents, the first situation, we have 2m cubed times 2m cubed. All right, and so in this case, we have the addition property of exponents. So we'll deal with the numbers. 2 times 2 is 4. But when we look at this m3 and this m3, it's like saying m3 plus 3. So we add in this situation. All right, so 4m, this would be IQ 4m to the 6th power because the 2 3's are added. In this situation, when you have the same base, when you're multiplied in this situation, you just basically add. If this was a 3 and a 2, then it would be m to the 5th. Because it would be 3 plus 2. The second situation you could find yourself in is, well, I'll give you 2 examples of this second situation. It's when you have a number and a variable with a parentheses. So let's say we have 4r to the 0 power. And then that's going to be raised to the 4th power. Anytime we raise anything to the 0 power, I don't care if it's 25 to the 0 power, if it's 8 to the 0 power, if it's raised to the 0 power, the answer is always going to be 1. So when you see this r to the 0 power, slash that and just think of it as a 1. 4 times 1 is 4. So now this is the power of a power rule that we're using. And so it will be basically 4 times 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 32. 64 times another 4 would actually be 256. So it's very important that you understand. Now, let's give us a normal situation where we have 4a cubed, and then we have a 2 outside of the parentheses. The 2 is going to deal with the 4. 4 times 4 is 16. And then the 2 is going to deal with the 8 to the third, but it's going to be multiplied. So 8 to the 6th power, because 2 times 3 is 6. So what I recommend to stay structured and keep yourself out of trouble is square the 4, which is 16, and then apply the exponent or power over power rule. 2 times 3 is 6. So 8 to the 6th power. When you're solving these exponents, you can never, ever have a negative number. And again, go to my exponents video and you can find out why. Keep those questions coming, guys. This is a decent one. We've touched on this, but I will go ahead and answer it since you sent the question. Now, in this situation, what we have is okay, but you can hear me, right, TJ? As long as you can hear me, that's what's important. Only Old Navy. Welcome to the room. I don't recognize, I don't think I've seen your tag before, but welcome to the room. We're here every Friday, and this is for Old Navy. We're here every Friday solving ASVAB, AFOQT, ASTB, OAR, and United States Army Civic questions. So every Friday night, 9 to 11, I'm here. So welcome to my channel. All right. Finding a slope from an equation. Cool. And if you see at the top of the message board, what you can do is take your smartphone, snap a picture, and you can send a question to that email. And if you have any questions about mechanical comprehension or anything, I will help you solve them. So, somebody sent a question about finding the slope of a line from an equation. Normally, there are 2 forms of linear equations. All right, but in order to find the slope of a line, we need to convert whatever it is. Sometimes it'll already be in this form, which is y equals mx plus b. All right, but don't let that throw you off. All right, because your question will like this: y negative 5 over 2x minus 5. Right. So this is telling you it's a negative slope. If it is a positive slope, if I learn how to spell, we have our x-axis and our y-axis. If we look at it from left to right, it's going to run like upstairs. If it is a negative slope, we've got our x-axis and our y-axis going to run downstairs. So this negative symbol is telling me that it's going downhill. Now another thing is the negative 5 is our y-intercept. It's telling you where it's going to intercept the y-axis. So when we have our x-axis and our y-axis, this is going to let's see, 1, 2, 3, 4, 5. It is going to move through the y-axis negative 5 points from the origin. All right, but let's not get off track here because the subscriber is asking how to find the slope of this particular line, which is y negative 5 over 2x minus 5. The slope is actually here, and that's what m represents. This is called the slope-intercept formula, and this m represents whatever's attached to the x is actually the slope. So the slope would be 5/2, which means whatever point you're at, this is a negative, so it's fall over run. And what we mean by that is that if you take any point on that line, the next point is going to be 1, 2, 3, 4, 5 in the negative direction, and it's going to run 1, 2. So the line will look something like that, but it will run through the -5 on the y-axis. So when it's negative, it is fall over run. If it's positive, then it is rise over run, which would look like that. So we go up a couple points and it will run. If it was positive, 5/2, then it will go up 1, 2, 3, 4, 5 points, and you go over 2, and then that will be your next point. Right. Okay, this is not too bad. A lot of people, they see polynomials and they kind of get all freaked out or whatever, and they're really not that serious. Right? In this particular case, the subscriber is asking to solve a question and it's saying find the product, and it's concerning multiplying polynomials. So in this particular case, we have 6v, and in parentheses, we have 2v plus 3. All right, now, in this situation, the 6v is going to be distributed, which means it's going to be 6v is going to be multiplied by 2v, and 6v is going to be multiplied by positive 3. So 6v times 2v is actually going to be 12, because the 6 times 2 is 12, and then v times v is actually going to be v squared. All right, and then the 6v is going to be multiplied by the 3, and that will give us 18v. 6v times 3 is 18v, and that's basically your final answer. They sent me a second situation where we have 4n plus 1, and then 2n plus 6. Now, in this situation, we have to do something called foiling. What the heck does FOIL mean? FOIL means first. I'm just going to put OPP for opposite, not OPP. Shout out to, who's that? Not Naughty by Nature. You down with OPP? Inside. And then last. So, the first two terms we're going to multiply with each other, and that will give us 8n squared, because 4n times 2n, 4 times 2 is 8, n times n is n squared. So 8n squared. Now the opposite terms, which is 4n and 6, which would be 24n, then the inside, which is 1 times 2n, which would just be 2n, and then the last two terms, 1 and 6, which would be positive 6. Now we have to combine like terms in this situation. So our final answer is going to be 8n squared plus 26n plus 6. And so I believe this particular subscriber that sent this question is at work, and they know that this is, so Old Navy, just so you know, or only Old Navy, what you can do, even if like you have to work and you can't make the live stream, you can send emails and a bounce back from, you know, the questions that people that come to the live stream have, and the questions that I get in email. And if you're at work and you can't make it, you can still send questions. So in this particular case, we had to FOIL. In this particular case, we had to distribute. So multiplying polynomials. Excuse me. good one. And I try to touch on questions that trying to find something interesting. Now, some of the hardest questions that you are going to come across are word problems. The word problems are really not that bad. You just have to have a system for breaking them down. All right, and let's see here. For instance, we have a situation where, in this particular word problem, I'll verbally okay, so the question is as follows. One recruit can complete a certain assignment in 40 minutes. Another recruit can do the same assignment in 1 hour. How long will it take them both to complete the assignment if they do it together? Our answers are 12, 18 minutes, 24 minutes, and 30 minutes. So, like I said, one recruit can do the assignment in 40 minutes, the other one can do it in 60 minutes, but they say 1 hour. That's how we set it up. This is the one recruit that can do it in 40 minutes. This is the other recruit that can do it in 1 hour. And it's one job. So this is what I do. I look for the lowest common multiple between 40 and 60. The lowest common multiple is 120, 120. So as a result, what needs to happen is each one of these terms needs to be multiplied by 120. So 120 times x over 40 will actually be 3x, and 60, x over 60 multiplied by 120 will actually be 2x, and then 1 times 120 will actually be 120. So now we combine like terms, we have 5x equals 120. Right. And what we need to do is we need to divide both sides by 5. So we come to the side here, we put our 5 up, we put our 120, and I'll add a decimal for accuracy. 5 cannot go into 1, but it can go into 12 2 times. With 10 here, we subtract, we get a 2. And then the 0 drops, and 4 will complete it. 0. So x is equal to 24. And that's how many minutes? Answer C. All right, so with word problems, you got to kind of dig in, you got to kind of pick them apart, and you have to have an approach to solving them. I've seen this one before. This is concerning the addition and subtraction. Now, anybody that's been watching my videos, I actually also have videos on the radicals, solving radicals. And you can go and you can look up that video, you can put in my name and then type radicals next to it and the video will pop up. In this particular question, I think this came from like a old test sample. Put 5 root 12 minus 2 root 27. What we need to do is we need to break down. This is like saying 5 times root 12 and saying negative 2 times root 27. But when we break this down, I see 5, I see 4, and I see a 3, because the square root of 4 times the square root of 3 is equal to the square root of 12. And when I see this, I see the square root of 9, and then the square root of 3. Because the square root of 9 times the square root of 3 is equal to the square root of 27. So we bring this down, 5 comes down. The square root of 4 is 2. The root 3 comes down. Right? 2, 9 breaks down into a 3. And then we have root 3. And so 5 times 2 is 10. Root 3. And then we have negative 6 root 3. And our final answer, we look at these, they're the same family, so we deal with the 10 minus 6, which is 4. And then we bring down the root 3 together. Like, if you guys understand that, just type in clear. Okay, I'm having confusion with formulas when finding the mechanical advantage. Okay, I just saw that. Now, what particular situation are you looking for mechanical advantage in? Is it a lever question? Is it a pulley question? Is it a wedge question? What particular type of questions are you having issues with finding the mechanical advantage? And I understand there's a time delay, so you can type it in. Okay, only Old Navy. I don't see a response yet. So I will give you two questions. And also, Old Navy, which test are you preparing for? That's another question I have for you, and you can answer that. But in the meantime, I will dive into a couple situations that you could run into on your test. The first one is the pulley system. Let's say in this particular pulley system, we have a 600-pound weight. And only on maybe this is you standing on the side here. And you're pulling a rope or a chain. And it is going through the pulley system. What I suggest you use, sorry, I can't find the question now. ASVAB. Okay. So this is a particular type of pulley question you could run into on the ASVAB. We have a 600-pound weight. You're pulling a rope or a chain, and then we have our pulleys. Now, pulley is a simple machine, and it multiplies our effort that we put into the simple machine. And so in this particular pulley system, we have our pulleys there, and you can see the rope or the chain actually circulating through the system here. And basically what I recommend you do is a horizontal line test. Now, you do not count, and I'll put don't count. You do not count the pull line. I do make a horizontal line, and I see how many ropes or chains you touch. So I have 1, 2, 3, 4. All right, so that is the mechanical advantage. So you definitely don't really need to depend on the formula for that. You can look at it, you can do a horizontal line test, and you can determine that the mechanical advantage is 4. Now, like I said before, the pulley system is a simple machine, and it multiplies our effort right, so basically, when we have our mechanical advantage, we can take the weight of the load that we're trying to lift that will tell us how much we need to pull. So 600 divided by 4 is 150. So we can use 150 pounds of pull to lift 600 pounds, and that's pretty good. Like I said, that is the function of a simple machine. It multiplies our effort. So we put in 150 pounds of effort in order to lift 600 pounds. I think that's pretty cool. All right. The next situation of mechanical advantage, or trying to compute mechanical advantage, is it normally comes in the form of trying to think of something. I would say this. Well, I do have an example. I just kind of, let's say we have a pickup truck. And the particular lift gate, or the gate, is 3 feet above the ground, but our ramp is 9 feet long. In this particular situation, the mechanical advantage is height divided by the distance. So the mechanical advantage is 3. 3 times 3 is 9. So if we had a 300-pound barrel and we needed to roll it up, or calculate how much force we need to roll it up. We take the weight and we divide by 3, and we only need 100 pounds of force in order to roll this up. So we don't need to use 300 pounds. If we were just standing on the side and there was no ramp, then we would actually have to exert 300 pounds of force in order to get that up there. But since we put it on a ramp, 9 feet long, and it's 3 feet high, we've determined our mechanical advantage, and we only need 100 pounds of force. This is why most hospitals have wheelchair ramps. Okay, you don't have to lift the whole person's body in the wheelchair ramp. You can just roll them up the ramp, because there's a mechanical advantage. And I know a lot of people didn't realize that those ramps at hospitals are actually simple machines. They're simple machines too. It's a ramp, or somebody call it an inclined plane. It is said that this was even a way of getting the boulders or blocks to different levels on pyramids when they were building them many years ago. So like, wow, this is a big, massive stone. How did they get it up here? They probably used ramp systems, or that's what it said in maybe a couple books that I read. Right. I think the answer to your question is 9. But I'm gonna pick this apart to make sure I'm getting all the details. And what are the answer options on the Old Navy? What are the answer options? I'm kind of thinking there's a 9 somewhere there. I could be wrong, but type in the answer options for that question. If the green box is 72 feet from the fulcrum, and I'd be curious to know which type of lever system this is, because I can draw fulcrum, and if it's a class 1, then what this is possibly telling me is that some object is 72 feet away from the fulcrum, but I don't know. If the green box And yeah, you probably should have took a snapshot and sent it to my email. But if the green box is 72 feet from the fulcrum and a certain force is applied 8 feet from the fulcrum, it's probably the 9, class 1 lever system. But, all right, I'm reading along. Certain force is applied 8 feet from the fulcrum. All right, so on this side, we have something 8 feet away from the fulcrum. We're going to apply a force. And then, yeah, I need more information. I need to know what you're telling me is there's a green box. Okay, so there's a green box, and I'll use a green marker. So there's a green box 72 feet from the fulcrum. And a certain force is applied 8 feet from the fulcrum at the blue arrow balances the lever. What is the mechanical advantage? So, do I have a blue? Don't have a blue. But I'm assuming that the blue arrow is here. I would love to see a picture of this question, though. The diagram isn't labeled like your tutorials. It's a seesaw with a green box on one side, the fulcrum closer to the green box, and a blue arrow on the other end. I would just like you to take a picture of this, man. Even if, you know, take your smartphone or your iPhone and just snap a picture. Because I would like to see certain weights. So hopefully what I'll do is if you email me that particular question, and then I can kind of like see it and see where it's going. I mean, I understand that you are typing it out and stuff like that, but I would just like to see it. Okay. So I'm gonna, and I apologize only on there, but I just feel like I don't have enough information on that. And just, if you could send me a picture of that question, I would love to address it. And even if you don't do it tonight, it could be tomorrow, whatever day. And so, yeah, I really do want to answer this question, but all right, I am typing it in now, sir. There it is. All right, and hopefully you get that over to me pretty soon. I'm digging back into the questions. Wow, okay, aviation and nautical information. What is wake turbulence? Okay, wake turbulence is a situation where an aircraft generating lift causes a disturbance in the air. Think of it like, let's say you're in a small fishing boat and then a big giant boat just kind of happens to just pass by you. Well, it's going to cause a wake, and basically like a wake turbulence in the water. But we have to be very, very careful if we're the small guy or the smaller aircraft. Because if we have a larger aircraft producing lift, as the airplane flies through, and let's look at the wing from a top view. If we looked at it from the top view, we have airflow patterns flowing inside towards the fuselage. But on the bottom, the airflow tends to flow outwards. So what happens at the, and this is a rear view now of the aircraft, so this is the tail of the aircraft, horizontal stabilizer, and here's the wings. So what happens is we get disturbances as the wings cut through the air. And this is a rear view, like as if we're flying behind the aircraft. Here, we're following the aircraft, and what happens is we get this disturbance, this air disturbance pattern. That is the wake turbulence. So if you're flying behind this aircraft and lower, you could possibly run into the wake turbulence, and it will rock the hell out of you. So what we do is we stay above that particular aircraft's flight path or change direction. All right. Wake turbulence is a really, really big concern for airport operations, because if this aircraft is landing, all right, it's going to be producing wake turbulence the whole time it's there, and if it's taking off, it's going to be generating wake turbulence. So if we're coming in behind this aircraft, we want to stay above its flight path and land past the touchdown point. And if we're taking off behind a very, very large aircraft, we want to stay above its flight path. Okay, and like I said, you can also change direction. You can even wait for a little bit and allow the wake turbulence to dissipate and fall to the ground, and then it won't be a factor. And the air traffic controller will, don't laugh at my artwork, that's my control tower. We'll just say caution wake turbulence. You're number 2 behind a 737-300, caution wake turbulence, if you're a smaller aircraft. Sometimes the air traffic controller will kind of delay your departure to allow the wake turbulence to dissipate. But if you're landing, normally there's more airplanes coming in. And, when they clear you to land, they'll just be like, Cessna 12345, you're cleared to land runway 27, caution wake turbulence. You're number 2 behind a Boeing 767 or Airbus 330. All right. And so he's communicating, he or she is communicating. Listen, a large aircraft just landed. Keep your eyes open, watch where they touch down, and make sure you land past that point. Because after it touches down, the wings stop producing lift, and then you won't have the disturbance anymore. Okay. All right, so our hour is up. People new to the room, I thank you guys for coming. Again, I'm here every Friday, 9 o'clock. So, if you can, just try to be here 9 o'clock sharp. Sometimes I don't due to, whatever, life. I may not start at 9 o'clock on the dot. It might be 9:05 or something like that. So I might be 5 minutes late, getting things set up and everything. So if you don't see me immediately at 9, don't freak out like, oh man, where is he at? Okay. Sometimes due to the YouTube system that we're using, sometimes it's hard to get the encoder, or the encoder gives us problems setting things up. Sometimes we get a bad, I don't want to say a bad server, but I think that's what it is, when we're setting up. So again, closing out. Thanks for providing the questions, guys. I'm Kino from STEMwithKino.com. STEM stands for Science, Technology, Engineering, and Math. If you're preparing for the AFOQT, the ASTB, the OAR, SIFT, and I guess I should mention ASVAB is the Armed Services Vocational Aptitude Battery Test. The AFOQT is the Armed Forces Officer Qualification Test. The ASTB is the Aviation Selection Test Battery for the United States Navy, Marine Corps, and Coast Guard. There is a non-flying version of this test, which is called the OAR, which is the Officer's Aptitude Rating. And then the United States Army helicopter pilots, they take the SIFT, which is the Standard Instrument for Flight Training. All right, so I guess I'll just close out with that. If you guys are interested in my clients, any of my clients in the room that are interested in the Google Hangout, just shoot me an email. And I do 9 to 10 in a free live stream, but if you're a client and you've done at least 2 hours with me, after 10 o'clock, 10 to 11, what I do is a Google Hangout, which is just like a video conference, getting all the guys in and they can ask questions and actually talk to me in a video conference. So if you like this video, if you like this presentation, please hit the like button. Please share on your social media networks, because I don't think there's a lot of guys that are just kind of just out there solving questions for these tests. And also, I forgot to mention, or I failed to mention, Federal Aviation Administration exams, from private pilot all the way up to airline transport pilot. All the instructor ratings, your initial, your instrument, your multi-engine, or the ground instructor ratings. I've earned all those ratings. Okay, so I am an expert, and I'm not saying like Big Willie or anything like that, but I'm an expert. I've been dealing with these exams for years, and I know how to help you prepare for them. So thanks, and this is the part where I give you the finger. Good night.